Hi there, Math 7 students. We're going to do the recording here to help prepare you for our next test, which is coming up on January the 20th, and it's going to cover lessons 11 to 19. So please, actually I believe it's 11 to 19. I'll check that for you guys. Anyways, please practice all these questions and make sure you can get all of them. Watch the recording and then practice all the questions on the PDF file. I was wondering what the weather is like where you guys are right now. Here in Edmonton, we've had a lot of snow, probably the most snow I can remember in the last 15 years or so. So anyways, needless to say, it's kept me fairly busy, doing a lot of shoveling, but that's a good thing since as an online teacher, I need to get out there and do some physical exercise, right? So anyways, here we go. We're going to get into the first question here, which has to do with estimation. Estimation is a really important skill in math. It doesn't only help you with jelly bean guessing contests, but a lot of other things in life as well. So we'll get on to the first question. First question says, estimate the following calculation to the nearest whole number. And so we need to round each of these numbers up or down to the nearest whole number. Now 8.6, because we have 5 or greater in the tens column, we're going to round that up to 9. So 8.6 becomes 9, whereas 4.1 is going to round down to 4 because we have less than 5 in the tens column. Okay, so we've rounded up to 9 and rounded down to 4. And now we're going to subtract 9 minus 4. And I put here 8 minus 4. It should be 9 minus 4. Okay, so 9 minus 4 equals 5. Okay, so that's how we do the first one. And let's move on to the next question. So we see this lady here, she's zooming by on her her kind of walker aid type device. So anyways, we've got a race here between Jocelyn and Martine. It says that Jocelyn took 72.76 seconds to run 300 meters, and Martine took 87.53 seconds. And the question is, how many seconds faster was Jocelyn than Martine? So first of all, it's always good to write out kind of the basic formula, the overall formula you're using to solve the question. So we say Martine's time minus Jocelyn's time is how much Jocelyn is faster than Martine. Okay, so now we just plug in the numbers underneath each one of those spots in the formula, and when we do the math, we can set the numbers up like this, one below each other, and then we can practice doing it using subtraction by hand rather than our calculator. So 3 minus 6 we can't do, we make that into 13, borrow from the next column, so we're going to cross out the 5 and make that into a 4. Okay, now we can't do 4 minus 7, so we borrow from the next column. 14 minus 7 is 7. We write that down. Okay, and we borrowed from the next column, which gives us a 4 there. Sorry, not a 4, it should be a 6. Let's try that again. Okay, so that should be a 6. 6 minus 2 is 4. We write down the 4. And then we have 8 minus 7 is 1. So 14.77. So Jocelyn is 14.77 seconds faster than Martine. Okay, great stuff. So moving on to the next one. The next question says, what is the cost of decimal 34 kilograms of birdseed at 89 cents for each kilogram? So the formula we use here is we multiply the unit cost, that's the cost per kilogram, by the number of kilograms. And we'll see that that gives us the cost. Now here's why it gives us the cost. If we have cost per kilogram, written like this, cost divided by kilogram, divided by number of kilograms, we have kilograms on top here and kilograms on bottom here. They're going to cancel out. Because we have the same thing on top and bottom, they just cancel out, and that leaves us with the cost. So that's why this formula is used to figure out the cost. Okay, so now that we know the formula, let's plug in the numbers we have. So the question says it's 89 cents for each kilogram, so we're going to write 89 cents per kilogram. Then we multiply it by the number of kilograms, and when we do the multiplication, we're going to get decimal 3026. Now, because that's in dollars, that would actually represent about 30 cents. Okay, so when we write the answer, we say it costs about 30 cents for each kilogram of seed. Okay, right on. So next question here deals with a rabbit run. We actually have a rabbit ourselves. Her name is Goldie Hops. And yeah, she's a lot of fun. I don't know if you guys have any pets. So anyways, this question says, in her backyard, Julie has a rabbit run that is 1.4 meters long and decimal 8 meters wide. What is the area of the rabbit run? Okay, so how do we find area? Area of any rectangle is length times width. Okay, so here's the basic diagram you're going to use to find the area of any rectangle. Okay, so now we label the length and width given the numbers that we have in this question, 1.4 and 0.8. And then we multiply length times width. We multiply the two numbers, and we get 1.12, and it's got to be meters squared. Remember, we always need to put the units in all of our answers, and because it's meters times meters, the units for area are going to be meters squared. All right, so we got a picture here of someone working at a cash register. This question says, suppose Anik works 6.5 hours each week. After working for a year, she gets a raise from $8.25 for each hour to $8.50 for each hour. How much more money will she earn in a week? So how do you find out how much money she makes in any week? Well, what we do, money earned, that's in a week, is equal to the hourly wage times the number of hours worked in that week. That makes sense, right? Okay, so that's the basic formula. Now, to find out how much extra money she's making in a week now that she's got a raise, what we're going to do, we're going to find the money earned at $5 per hour, that's with the raise, and subtract the money she was making when she had the lower wage, $8.25 an hour. Okay, so these are the two formulas we're going to use. So first we need to find how much money she makes in a week at the new amount, $8.50 an hour. Well, what we do is we multiply $8.50 per hour, or $8.50 divided by hour, times 6.5 hours. And you can see that hours cross out and you're left with dollars, $55.25. Now let's do the same calculation for the $8.25 per hour wage. Okay, so when we do that, we get $53.63. So now what we need to do is we need to take the money earned at $8.50 per hour, subtract the money earned at $8.25 per hour, and that's going to be the extra money she's making at the higher wage. Okay, so we found that at $8.50 an hour she was making this much a week. You subtract off the amount she was making at $8.25 an hour, and then you can see that she's making an extra $1.62 per week. It's not a lot of money, but then she's not working a lot of hours either. Okay, so this painting here is a famous painting by Michelangelo. You might have heard of it before. It's the painting of the Sistine Chapel. This one must have given him a lot of pain in the neck because he's painting the ceiling. It's a really amazing painting though. But yeah, he must have been craning his neck quite a bit. So, speaking of painting, our question here says Suki is painting her bedroom ceiling. The ceiling is 4.6 meters long and 3.4 meters wide. Suki has one can of paint which will cover 11 meters squared. That much area. Does she have enough paint to put 2 coats on the ceiling? Alright, so let's look at the different steps we're going to use to solve this. First of all, we need to find out what's the area of the ceiling that she's going to be painting. So again, area is length times width. We're going to multiply these two numbers together. Then we need to multiply this area by 2 because she's going to be using 2 coats of paint. So that's the area that she needs to paint. So what you need to do is you need to compare the area that she needs to paint with the area that 1 can of paint that she has will allow her to paint, and see if she has enough paint. Okay, so we know that 1 can of paint is going to paint 11 meters squared. Let's find out what the area is that she needs to paint using A and B, and find out if 11 meters squared that 1 can will allow her to paint is going to be enough paint. Okay, so again we're going to use area equals length times width, and so these are the areas we're given for the ceiling, or rather the length and width we're given for the ceiling, so we're going to multiply them to get the area, and that's 15.6 meters squared, 15.64. Okay, so that's the area of the ceiling, but what do we have to do again to that area? We need to multiply it by 2 because we were going to put 2 coats of paint on it. So when we multiply it by 2, we're going to get 31.28 meters squared. So that's how much paint she needs to have. Let's find out if she has enough. Does she have 31.28 meters squared? Well, the question says that 1 can of paint will paint 22 meters squared. And so I should have said that right here. I put 11, but I changed it, and it should be 22 meters squared. Okay, so she has the ability to paint 22 meters squared using 1 can of paint, but we figured out that if she's going to put 2 coats on, she needs to have 31.28 meters squared. That's how much area she needs to paint. So the 22 meters provided by 1 can is not going to be enough. So to answer the question, does she have enough paint? The answer is no. She could only put on 1 coat of paint, not 2. Okay, next question. How many 0.25 liter glasses can you fill with a 1.85 liter bottle of water? Alright, so how are we going to do that one? What do you guys think? Are we going to use addition here? Are we going to use multiplication or division? Well, we're going to use division, and let's see why this is. So what we're doing in this problem, we're using this big bottle to fill a number of glasses. So this big bottle is 1.85 liters, and let's say that about this much of it will fill 0.25 liters, which is 1 glass. I'll just put that in brackets, 1 glass. Well, you can see that what you need to do to solve this problem is to find out how many of these 0.25 liter sections are there. Like, can you divide it so that there's 5 lines that are going to make each of them being 0.25 liters, so 5 glasses? Or how many of the glasses will there be? So you can see that we need to divide this number, the total volume of the bottle, by the volume for each glass, and that will tell you how many glasses will fit in this bottle. Okay, so divide volume of bottle by volume of 1 glass. Alright, so let's do that then. So we take the 1.85 liters, divide by 0.25 liters, and we get 7.4. So we can fill 7.4 glasses using the bottle. Alright, so at this point we're going to talk about order of operations. You remember that special phrase that helps us remember order of operations? And that's BEDMAS. Remember again, BEDMAS tells us that we do brackets first, then exponents, then we use division or multiplication, whichever comes first, going from left to right, the order you would read in. Same with addition and subtraction. Okay, so let's use BEDMAS to solve this problem here. Well, first we can see that there's no B and E, in other words, no brackets and exponents, so we're going to go to division and multiplication, whichever comes first. Well, you can see in this problem that division comes first. So first of all, we're going to divide 11.8 by 3, and when we do that, we get 3.9. So all I did is I wrote that answer below as my first step in the problem. So we've done division, And now we have this here, and we can see that using BEDMAS, we're still going to use division or multiplication first, so we're going to do this multiplication. And when we do it, we're going to get 7.8. So we write that below, and now we have this as our next step in the problem. Well, now we do addition or subtraction, and we have two subtractions, so we're going to do one subtraction and get an answer of 6.2, and we have one more subtraction, and we'll get 5. All right. Let's do another order of operations problem. So in this situation, we do have a brackets, and so we need to do brackets first. Now, within the brackets, there's subtraction and multiplication. So within the brackets, we are going to do multiplication first because it comes before addition and subtraction. Okay, so we're going to do this multiplication of 2 times 2, and we get 4. Then we do the subtraction that's in the brackets. 4.8 minus 4 is 0.8. Now we have this. And the only thing we're left with is subtraction. So we're going to do that, and we get 6.32. All right, right on. So, next question here is going to talk about making a mistake. Now, everyone makes mistakes sometimes, right? I don't know if you guys knew this before, but Thomas Edison, who invented the light bulb, took somewhere around 10,000 tries to get the light bulb to work properly. Now, you could look at it and say that he failed 10,000 times, or you could say that he didn't give up and he was finally successful. Now, the solution below has just one error. So let's see if we can find out what the error is, and let's explain what caused the error. So you can see there's no brackets here and no exponents, so we're going to do division or multiplication first. So we would do this multiplication, and we get this answer. So far, so good. And now we have this stage of the problem. Now, at this stage in the problem, again, we should still be doing division or multiplication first. However, if we did that, we would get 6 times 4 and 20. We would get 24. But we haven't done that. So what they must have done is gone 12.96 minus 6. In other words, they did subtraction first and got this as an answer instead of doing multiplication. So that's the problem. So we would say the error here is they did subtraction before multiplication, and that's why they got the wrong answer. Okay, here's something about Arnold Schwarzenegger. He used to be an actor. Well, he still is an actor, does a little bit of acting. He used to do a lot more. Then he became the governor of California, and he was in the Terminator movies. Not movies I've watched, but that's a movie he's kind of famous for. So anyways, talking about Terminator, what does the word terminate mean? If something terminates, it ends. So if we're talking about a terminating decimal, it ends. It comes to an end. So decimal 125 comes to an end. There's no more digits. A repeating decimal, on the other hand, goes on forever. So if you have decimal 3333333, just keeps going on forever. You can always write more 3's. So that's the difference between a terminating and repeating decimal. So for this question, for each of the following, decide whether the decimal equivalent of each fraction terminates or repeats. In other words, we need to change the fraction into a decimal and then see if the decimal terminates or repeats. So when we do 3, it shouldn't be 3/4. I meant that to be 2/3. When you divide 2 by 3, you'll get 0.67, and that terminates. It ends, right? If you take 4 and divide it by 9, you get 0.444, and it goes on forever. So this is a repeating decimal. Okay, how about this next one? 9 divided by 14, 0.62485. Now, when you look on your calculator, you're going to see more digits coming after that. The reason we know it's a terminating decimal and not a repeating one is we don't see any of the digits on our calculator repeating over again. So that's why we know that it is going to terminate eventually, because we don't see any numbers repeating. Okay, if we do 17 divided by 20, it's 0.85. Again, it terminates, it ends. Right on. Okay, question number 12, write the decimal as a fraction. So how do we do that? Well, we look at the last digit and we ask ourselves, what column is it in? Okay, these are tenths, hundredths, and thousands. So this is in the thousands column. And that's how we decide what number to divide it by. Now, since it's in the thousands column, we divide by 1,000. Okay, so I'm just going to underline that. It's in the thousandth column. And so you can see here that we took the number 158. We don't have any decimal in it now. We just have the number 158. And we're dividing that by 1,000. So this here is the fraction equivalent of the decimal 0.158. So always remember these two steps that are in red here. Okay, next question. This is talking about ordering numbers from least to greatest. You know, sometimes you'll take pictures and you'll organize everyone in the picture from smallest to largest, that sort of thing. This guy here was Robert Wadlow. You might have heard of him before. He was the tallest man, at least in the last couple hundred years. He was 8'11". Okay, so talking about ordering numbers from least to greatest, here's the numbers that we have, and somehow we have to put them in order from least to greatest. The only problem is some of these numbers are fractions and some are decimals. So we have to put all the numbers into the same form in order to be able to put them in the order from least to greatest. So we need to put all of them into decimal form. So here, first of all, are all the numbers, and below them I wrote the decimal. So I divided 1 by 8 on my calculator, got this, divided 5 by 7, I got this. Sometimes we already had a decimal, so we just write it underneath. Now we've got the decimal equivalent. So now what we do is we order the decimals from smallest to least, but above those decimals we put the number they actually stood for, the number we started with. Those were the numbers that we needed to order from smallest to least. We can't just put these decimals as our answer, because that's not what the question was asking for. It said to organize these numbers from smallest to least. So we just write the number that we had started with in the beginning above the decimals that we found for them. And here they are. So here's those numbers organized from least to greatest. Okay. Question 14, it says find the answer to each of the following. Okay, so we're going to have negative and positive numbers, and let's see how we find out what the answer is. Well, first of all, you can rewrite a lot of these questions. Getting rid of the brackets often helps. So what I'm doing, I'm taking away this bracket here and I'm just putting -6, and because I have plus 2, that just equals +2, right? So I just put +2. So I have -6 plus 2. That looks a lot more simple than the original question, right? Now we can figure out what the answer is. So what we always do when one of the numbers is negative and one is positive, we just find out which is larger. Okay? So since -6 is larger than +2, the answer is going to be negative. So all you do is you find out how much larger 6 is than 2. It's 4 larger, right? So the answer is going to be -4. We knew it was going to be negative because -6 was larger. Okay? It's kind of like going 6 to the left. Let's say left stands for negative, right stands for positive. This is like going 6 to the left and then 2 to the right. Okay? That can often help you to find the answer as well. I'll just write that out. Okay? So this is like going, if this here is 0, right? First of all, we go 6 to the left, but then if right is positive, then we go 2 to the right, and you can see that it makes sense that we're now going to be at a place that's going to be -4, right? So again, you might find that drawing these number lines helps you to figure things out. Sorry, I wrote -4 and that should have been -2. Okay? But the answer should be -4. Okay, let's do the next one. Again, try to rewrite the question if you can. So first we have minus 5. Let's just write it as minus 5. Now when you have plus minus 3, plus and minus beside each other is the same as just minus. So I just wrote it as minus 3. Okay, so I just wrote plus, minus beside each other makes a minus. Now that's a lot more simple, isn't it? Minus 5 minus 3. So the answer is going to be minus 8. It's like if you're already minus, let's say you've got a minus temperature and you go 3 more minus, you're going to have minus 8. Or if we were thinking about it like before when we said that minus is to the left, so we go minus 5, we could label that, and then we go another minus 3, that's going to be minus 8, right? Okay. Question C. Again, let's rewrite it. 19, we're just going to write as 19. We have plus minus 13, we're just going to write that as minus 13. Plus minus 5, we're just going to write as minus 5. Again, it looks a lot more simple. We just do 19 minus 13, that gives us 6. 6 minus 5 gives us 1. Not too bad, eh? Okay, let's check out D. Again, just rewrite it. Minus 10, we put minus 10. We have 2 minuses, we just put minus minus 18. Remember, whenever we have 2 minuses in a row, that equals a plus. Okay, so instead of having minus minus 18, we write plus 18. Now, in this situation, the 18 is a positive number. It's larger than the minus 10. 18 is 8 larger than 10. So our answer is going to be positive, and it's going to be 8. And again, if you wanted to use the number line, the left standing for minus, the right standing for positive, that can help. Okay, so I just found a picture of a lawyer from the internet. Lawyers, as you know, do a lot of explaining, proving things. So that's what this question is kind of about here, is being able to prove something. So it says, is the statement below true or false? Explain your reasoning. It says the sum of a negative integer and a positive integer is always positive. Okay, let's find out, is it always positive? Well, to do that, we want to think of some different examples. So in one situation, we'll think of a negative integer being larger than the positive integer, and in the other situation, we'll think of the positive integer being larger. And that will help us see if this always works. Okay, so it's talking about the sum of a negative and positive integer. So here's a negative, here's a positive. When we put them together, the positive is going to be bigger by 2. The answer is positive. Now in this situation, the negative number is larger. So now we have minus 8 plus 3. Oh boy, I put minus 3, that should be minus 5 as an answer. I'm not sure what's going on here, guys. Anyways, that should be minus 5. And so in this situation, you can see that the answer is negative. So this statement, the sum of a negative integer and a positive integer is always positive, not true. It depends which number is bigger. Is the negative number bigger or the positive number bigger? So again, to try out a question like this and to prove it, because that's what you'd have to do on the test, come up with some different sorts of answers and see what you get when you do the addition. Come up with one where a negative number is bigger and one where a positive number is bigger. All right. So we've got another one that's kind of similar here. It says, is the statement true or false? The sum of a negative integer. Okay, sorry, this is the same question, right? Question 15? Yeah. Okay, I know we do have another question that comes later that's going to be similar to that one. So question 16, Anthony hiked uphill from a valley that was 35 meters below sea level. Okay, so think of sea level as like 0. After an hour, he was 120 meters higher than where he started. Okay, so where did he start? He started at the point where he was 35 meters below. Later on, he was 120 meters higher than that. Using integers, determine how high he was above sea level. That's what we need to know. How high he was above sea level, or above zero, you could say. So it's really helpful to draw a diagram here. Okay, so he started off 35 meters below sea level. That's where he started. He ended up 120 meters higher than where? Than sea level? No. Higher than the point he started at, which was 35 meters below sea level. That's why we drew it like this. Okay? Now what was the question asking for? The question was asking for how high did he end up above sea level? So in other words, this part that I've marked off here, that's the length that we need to find. That shows the height above sea level. So how do we find that amount? Well, we take the length of this line, which is 120 meters, and subtract the length of this line, which is 35. That will give us the amount above sea level. So 120 meters minus 35 is 85. He ends up 85 meters above sea level. Okay, great stuff. So we've got one last question that has to do with proving something again. And what it says here, when you subtract a positive integer from another positive, the result is always positive. Okay, let's see if that's true. Again, let's look at different numbers and see if the statement's always true. So we subtract a positive from another positive. Okay, well here's a larger positive, and then we're subtracting a smaller one, and we get 5. Now we're subtracting a smaller positive, so we're taking away a larger one from it, and we're getting negative 5. So sometimes the answer's positive, sometimes it's negative. But here it said when you subtract a positive from another positive, the result is always positive. Again, not true. Sometimes it is, sometimes it's not. And again, the way to prove it, if you're going to have to answer this question, is to actually show it by using different numbers, different sizes of positive integers, and showing that sometimes you get a positive answer and sometimes a negative. Alright, so thanks guys for watching this recording. Again, I want to encourage you to practice all the questions until you can get them all on your own after watching the recording. Again, the test is on January the 20th, and it covers lessons, I believe it's 11 to 19, and I'll check that for you guys. So keep working really hard. God bless, and have an awesome day. Bye for now.